So, as Irene explained it, I'm a staff machine learning engineer here at Nubank. I mainly work with platform-related projects. So this is one of the projects that my team take care of. And that's it. So today I will be talking about Shepherd. That's our model monitoring solution and how we use it to scale this model monitoring tasks here at Nubank, and how this is important for us in this international expansion and supporting more customers and so on. So I will start briefly talking about what's model monitoring. I will not focus that much on this topic because the main focus of the presentation is the platform itself. So we can think about a model as a software that is constantly changing. And the main caveat here is that the changes happen even when we are not deploying new stuff. So we all know that a model usually behaves well with a previously known data distribution. So here we are basically saying that our models knows how to deal with the training data distributions, but not that well when the input data starts to follow a different distribution. And this is kind of like how the world works, because all the time people are changing their behavior and they are changing how everything works. Sometimes we are changing the targets, definition, and so on. And this way our models are also changing, even if we are not changing anything. So this is why model monitoring is so important, because we are trying to understand when those things are happening and act upon on these changes to avoid any tragedies and anything that may harm both the company and our users, because we are taking care of both. And I will start talking about the early days here at Nubank. So how things worked when we had a single product. So as some of you may know, Nubank started only with the credit card product. It was awesome product, but was a single product. And things are kind of easier to deal with because most of our solutions were tailored to solve credit-related problems. So everything we built, we just like focused on the single product in a single country. We didn't like need to deal with different languages or different problems. So we focused only on this thing. And our first model monitoring solution was a really like ad hoc solution. So basically what we delivered for data scientists and machine learning engineers was a set of common libraries. So we had like this common code that everyone could use, but we didn't have the standards for how you should use that common libraries or how should you present the data. And this ended up like being a bunch of Jupyter notebooks and people dealing with this coding in a not standardized way. So we replicated a lot of code and all the problems related to this lack of standards. And this was some of the challenges we had by that time. So as I said, lack of standards required a lot of code. We have like people copy and paste code all the time. It was really overfitted to this single use case that was the credit underwriting. And the code was non-versioned because we kept everything in those notebooks. So we didn't have versioning and so on. So had all these problems that by that time wasn't like such a big deal because the company wasn't that big. But since the company starts to grow, these problems starts to be like way more important than they used to be. So right now I'll be talking about our first iterations until we built this model monitoring solution. So as I said, everything started with this notebook solution with not like standardized code, a lot of copy paste and so on. And we moved from this solution to a more robust solution that was to put everything inside our ETL. So basically what we did was to move the model monitoring from this notebooks and so on approach to the ETL. So everything run like inside our data platform, but it still required like a lot of code. We didn't change it that much. The thing related to be focused on credit only instead of support different countries, different products. And also we end up coupling everything with the ETL. So the data visualizations, the alerts, everything was inside the ETL. And this came up like with a bunch of problems because having this coupling with the ETL, it kind of blocked us to move forward. So let's say I want to have like a more robust alert solution or a more robust data visualization. Everything was coupled to the ETL, so we couldn't change that much the things. And also, again, all the time data scientists writing code and like not focusing on the final product that was the dashboard itself and the analysis. Then we moved from this ETL solution to a code generation solution that things are still running on the ETL, but instead of having a data scientist or a machine learning engineer writing the code, what they were doing by that time was writing a configuration file, and we generated all the code related to the monitoring. It kind of helped us to scale the solution by that time, but it came up with a different set of problems. Because code generation may sound as something cool and something that works, but it brings a bunch of problems because the code generation may be flaky. It's really hard to update all the code we generated. Also, users were all the time having issues to know what's a generated code and what's a human wrote code. So they kind of mixed the two concepts together, and we kind of didn't fix it. Most of the problems we had. So we kind of knew that this solution was just an intermediate thing and that we would be changing things in the future. And this is when we just stopped everything that we were doing related to model monitoring. And we said, oh, since that we need to think about a long-term solution and a solution that allows Nubank to scale and something that we may be using within like 5 years or 10 years and something that we can keep extending and supporting all the different things that are happening within the company. And this is when we came up with Shepherd. That's our model monitoring solution. So the first thing that we did was to set a vision for this project, because prior to this, we were in this position where we are solving specific problems with a very like localized solutions. So nothing really tackled the big picture. So we can map with this vision that's provided tools to enable data scientists to easily set their model monitoring solution and empower machine learning engineers to build new monitoring strategies that target specific business needs. So here with this idea, we have two very important things. First one being that the model monitoring should be something really easy for data scientists. So they shouldn't be like investing a lot of time dealing with bugs or dealing with how to set something. Let's say I want to compute a metric and I have a lot of issues to compute this metric. And the other one is this one where we say we want to allow other things to build solutions that targets specific business needs. Because something that we saw over the years is that as a platform team, for us, it's really hard to cover all the business problems and tackle all those things because we kind of lack of context, and sometimes we are not that close to the business in order to build a very robust solution. So we just said, oh, maybe it's important that other people can extend our platform and build their own things. So in order to meet those requirements, we built a platform thinking about components, and each component was focused in a very well-defined responsibility. So we had things related to configuration, to orchestration, and visualization. I will later on explain what we are talking in each of those boxes. And we kind of set this list of things that were really important to our solution. So first one being that things should be really easy to configure. So we set easy configuration. Things also needs to be highly standardized. So we don't want people like, let's say, our Mexico team are doing things different from the Brazilian team. Everyone should be talking the same language and using the same tools. We also need something that needs to be really extensible, because we don't want to create this silo where only the platform team is the owner of this tool and the only ones delivering new solutions. And also that's one very important for everything here at Nubank. This thing needs to be scalable. So we want this solution to be working within 10 years and something that really supports the company and all the models we put in production. So right now I will start to go through the architecture of our solution. So here I will start with the configuration layer. So we thought like about a very like fancy solution. We would love to have like a user interface where people can configure things, but we had so many things to do in this project that we didn't have a lot of time to invest in this. So what we did is just create a backend that in the future may support a user interface, but that for now, it's basically a GitHub repository where we store configuration files. So a data scientist writes a configuration file, and from that file, we know how to compute data, which metrics they want to compute, and we create all the visualizations. And we move all those files to a storage that in our case is S3, that is the AWS storage, but it could be any backend to store data. And we build this way, thinking about the future, thinking about that one day we may use an API to do this. And it's kind of working for now. And people are kind of comfortable using it. So we started with this, focusing again in the easy configuration and in the standardization. And something that is pretty cool about this configuration file solution is that we managed to migrate everything that people wrote in the past for code generation to this new architecture, because the configuration kind of matches, so we can just copy all the old configurations that people were using to generate code to configure this set of new monitoring jobs. And from this configuration layer, we kind of move to this processing / orchestration layer. That's where most of the code lives. So I have a lot of things happening here. This architecture image is kind of a macro view. We do have some more things happening, but just to simplify things here, the core component of this part is what we call Shepherd controller. That is a closure service. here I'm just talking about Clojure because it's what we use here, but you can think about any microservice or something that can read Kafka messages. So this is the main thing that the service is doing. So here at Nubank, our ETL sends updates via Kafka messages saying this data is up to date and you can use it as you want. So what we did is just, okay, let's wait for the ETL updates. When my data is updated, I can process it and create all the monitoring metrics related to it. So this is what this service is doing. It keeps like reading those messages, and if a new job should be triggered, it triggers a Spark job that uses what we call here Shepherd processor. That's the core library with all the logic related to monitoring. So let's say you want to compute AUC. This is the library where the AUC is defined and how we create the metrics. And also we do have a meta store that's basically for us to keep control of which jobs has been triggered and the status of each of those jobs. And by the end of this process, we do have a BI loader that takes the data and loads to our analytical databases, so users can use those things. And something that is worth to highlight here is that all those things are decoupled from each other. And I think this is maybe one of the main takeaways from this architecture, is that we can replace the backend, we can replace the data sources as we want, as we need, and nothing should break in the platform. I will later on talk about this. We kind of validated some of these ideas, and this is really important for us to move forward, because if in the future we have a new set of requirements, we can replace pieces of this architecture by other things. Let's say the analytical database that we are using as of today doesn't scale anymore, so we can replace it by one that scales better than what we have as of today. And the last part of our architecture is the visualization layer. That's basically a command line to allow users to interact with which jobs run and their status, and also everything related to dashboards and alerts. And it's pretty cool here that we do have a set of standardized dashboards. So when a user sets a configuration for one of their jobs, they automatically will get all the alerts and all the dashboards related to that configuration. And this is really pretty cool for us because it allows people to not invest time building dashboards and this task that may be pretty boring and doesn't deliver like a lot of value when we are always focusing on value that people can deliver. And that's all for the architecture itself. And here is one example of how a configuration file would look like. I obviously kind of simplified it. People can put way more options and arguments here than the ones I set. But as you can see, we start saying which data set will trigger this job. And later on, we describe like which features I want to monitor, which features are numerical, which features are categorical, and also which metrics we want to compute. And from this configuration, as I explained it previously, we'll have Shepherd controller reading all the configurations and triggering jobs. And by the end of the day, what we would have is a dashboard that would look like this one. So we kind of tells the user when the data was updated. They have a set of filters that they can use, and they can see all the features they want. And this is basically how our solution works. And right now, I think I'm almost out of time, so I'll be talking about our results and next steps. So as results, today we are running 150 plus daily jobs. It's an awesome number for us, because we kind of are covering way more things that we could cover previously. We also managed to validate the extensibility of the platform, and this was something really important for us because we kind of designed it to be extensible, but we didn't validate that first. And today we kind of started to use it in other approaches. So today we have hourly jobs, and previously we only deal with daily jobs, and this is really important for us. We are also thinking about how to integrate other models that are not the models that use our core functionalities here in Nubank. Something that also we are testing is using this tool to other purposes besides the core model monitoring. And when I say besides core model monitoring, I'm talking about maybe policies monitoring and decision-making monitoring. So things that are not just the model output. And this is pretty cool because the tool kind of fits well in these use cases. And we are also support 16 different monitoring types. And for us, a monitoring type is a strategy. So let's say when you monitor the predictions of your model, it's one of the monitoring types. When you monitor the inputs of your model, it's a different monitoring type, and so on. So we kind of have a bunch of different strategies. And some of those strategies were developed by other teams besides the platform team. So it's pretty cool for us. And from the negative things, or like things that were not that good, we still need to improve the contribution flow, because sometimes I feel that the platform team can navigate through this massive architecture really well, but other things may have some problems. And I think this is kind of expected for such a big platform. And we are kind of thinking about how to fix this. Also, sometimes we do send too many false positive alerts. This is something that's challenging to fix, but it's not a problem from the platform itself. It's kind of a problem from the alerts strategy that we built. So we do have some room to fix this. Something that also we didn't have time to implement, but I think we may be able to do this in the future, is to have an out-of-box monitoring for the models. Since we designed the solution as this API idea, I think in the future we may have like, oh, you just deployed your model and here is a default monitoring for it. And I think this would be pretty cool. And the last one is that monitor decisions is still a challenge. Even other things are starting to test the tool for other purposes besides the model monitoring. The decisions itself, it's a challenge because we kind of lack of some standards for this decisions layer, and we need to kind of improve it prior to have a default monitoring for it, and so on. And I think that's it.